Okay, so in this lecture, we're going to look at the basics of the web and how the web works. This is chapter number 1 from the first book listed in the syllabus, which is the fundamentals of web development. So what are we going to cover in this lecture? We'll start off with the history of the internet and the web and define some of the key terms. Then we'll briefly look at the internet protocol layers and what purpose do they serve. We will also look at what client-server model is, which is essential to the working of the web. Then we will look at domain name system. What is the domain name system and how it is used behind the scenes when we browse the web. We will then look at what a uniform resource locator is and how it is used by the client and the server. Then we will look at the Hypertext Transfer Protocol, which is a very important application layer protocol for the web. And then we will look at what web servers are. So first of all, what is the web? Is internet and web the same thing? Many people use the terms internet and the World Wide Web or the web interchangeably, but in fact the two terms are not synonymous. The internet and the web are two separate but related things. The internet is a massive network of networks. It connects millions of computers together globally, forming a network in which any computer can communicate with any other computer as long as they are both connected to the internet. So information that travels over the internet does so through a variety of languages, which are known as the protocols. On the other hand, the World Wide Web, or simply the web, is a way of accessing information over the medium of internet. It is an information sharing model that is built on top of the internet. So the web uses the Hypertext Transfer Protocol to transmit data. It also utilizes browsers such as Internet Explorer or Chrome to access web documents, which are known as web pages, that are linked to each other through hyperlinks. So web documents also contain graphics, sound, text, and video. So World Wide Web is only a subset of the internet. So internet provides other services such as email, online gaming, and file transfer in addition to web browsing. So before we talk about internet, which is a form of digital communications, let's first look at how analog communication works. So let's take the example of telephone networks, where there is a dedicated connection between the caller and the receiver for the entire duration of the conversation. So the telephone networks are also known as circuit switched networks. So in circuit switching, there is a physical connection between two people through a series of physical switches, as you can see in this figure. So this type of communication has several weaknesses because of which it is not ideal for communication between computers. Firstly, you have to establish a link and maintain this link for the duration of the conversation. So because of which multiple conversations would not be possible at the same time. Also, the bandwidth is not efficiently utilized. So the bandwidth is wasted when the communication consists of only silences. In that scenario, the bandwidth is not utilized properly, which could be utilized for transmitting other useful data. So when digital communications were being researched, instead of using circuit switching, packet switching was proposed. So in packet switched networks, a continuous connection is not required between the two communicating partners. Their messages are split into smaller chunks, which are known as packets, which are routed to the appropriate destination based on the address. So each packet can take different route to the destination, and the message is then reassembled from these packets at the destination. So let's look at this figure in order to understand packet switching. We can see that the message here is broken into 3 packets, each of which has a sequence number to help in reassembly at the destination. So you can see here that each packet has taken a different route to the destination machine's network. where again it is then being reassembled using the sequence number. So packet switching has advantages over circuit switching. It is more robust because packets do not take a fixed route to the destination. So if one route fails, only some packets will fail to deliver. It is also more efficient because the cost of the link is then shared by many users. When you make a circuit switched phone call, the line is tied up for the entire duration of the call, whether you are talking or you are silent or on hold. However, in packet switching, that is not the case. So in 1960s, the first network, which was known as the ARPANET, was established by the US government. So ARPANET stands for Advanced Research Projects Agency Network. So it was a packet switched network, and it was used only for academic and scientific purposes. So it was the very first network that was established. So therefore it had a very small number of computers connected to it. In 1980s, ARPANET grew to a few hundred universities and other companies. In the meantime, alternate networks such as X.25 and Usenet were also established later, and they also grew quickly. So now there was one problem. So there were many individual networks, but these networks were not able to communicate with each other. In other words, a computer in ARPANET was not able to communicate with a computer in, for example, Usenet or the X.25 network. So in order to solve this problem, it was proposed to use a suite of communication protocols to allow computers on any two networks to talk to one another. A protocol is the name given to a formal set of publicly available rules that manage data exchange between 2 points. So in 1981, the protocols for the internet were published. They were known as the TCP/IP or Transmission Control Protocol / Internet Protocol Suite. So new networks began to adopt this communication model, while the old networks were transitioned over it. So this resulted in the growth of internet. So initial internet experience comprised of only email and text-based systems. So in 1990, the World Wide Web was born with an invention of a hypertext system by Tim Berners-Lee and Robert Galileo. So there were 5 features of the early web. And the first was that it should contain a uniform resource locator, or a URL, to uniquely identify a resource on the World Wide Web. Then the Hypertext Transfer Protocol, or HTTP, should be used to describe how requests and responses for the resources will operate. The third feature is the use of a software program, which was later called a web server software that can respond to HTTP requests. Then the hypertext markup language, or HTML, in order to publish documents. And lastly, a program which was later called a browser that can make HTTP requests from URLs and that can display the HTML that it receives in response from the server. Something else you should know is the World Wide Web Consortium, or W3C. It was founded in 1994 also by Tim Berners-Lee. So it is the organization that oversees the growth of the web. Also, you should know about the RFC, or the Request for Comments archive, which lists all of the internet and www protocols, concepts, and standards. So early websites were static, meaning that they did not change. They consisted only of HTML pages that looked identical for all the users at all times. So the only skill needed by a web developer at that time was that of the HTML language. So this figure shows how a static website works. So when a user's browser makes a request for a web page, that request goes to the server. The server retrieves the files from its hard drive and sends these files back to the browser. And the browser then displays the HTML page from the files retrieved from the server. However, soon the websites began to get more complicated as more and more websites began to use programs running on the web servers to generate content dynamically. These server-based programs would read content from the databases, interface with existing enterprise computer systems, communicate with financial institutions, and then output HTML that would be sent back to the user's browsers. This type of website is known as a dynamic website because the page content is being created at runtime by a program created by a programmer. This page content can vary from one user to the other. This figure shows the interaction between a user and a dynamic website. So when a user requests a PHP page through the web browser, so PHP is a server-side programming language. The server recognizes that it must run a dynamic script on its hard drive in order to generate the HTML page. So the server executes the script and outputs the HTML and sends the generated HTML and the corresponding image files to the user's browser, which displays these files. So in the mid-2000s, another buzzword was created, which was known as the Web 2.0. So this term had two meanings, one for the users and one for the developers. So from the user's perspective, the Web 2.0 referred to a more interactive experience where the users could contribute and consume web content. So it was a more user-driven web experience. So for example, in the case of Facebook, YouTube, and Wikipedia, the users not only consume web content, but they also contribute to it. From the developer's perspective, in Web 2.0, the programming logic exists both on the server and the browser. So in the browser, the programming language is known as JavaScript. So it runs inside the browser. And for the server, there are languages such as PHP and JSP. So let's now look at the internet protocols. So as we just discussed, until the communication protocols were invented, the internet did not grow much because of the disparate networks. So a communication protocol is a set of rules that the communicating partners use when they communicate. So these communication protocols have been implemented in every operating system, and they make fast web development possible. So if the web developers had to keep track of packet routing, transmission details, domain resolution, checksums, etc., it would be hard to get around to the matter of actually building the websites. So one of the essential Internet Protocol suite is the TCP/IP Internet Protocols, which were originally abstracted as a 4-layer stack. So later these layers were further subdivided into 5 or 7 layers. So layers communicate information up or down one level, but they need not worry about layers far above or below. Since we are focused on the top layer or the application layer, we will use the earliest and the simplest 4-layer network model. In this 4-layer network model, the link layer is at the very bottom, then we have the internet layer on top of the link layer, then we have the transport layer on top of the internet layer, and then finally we have the application layer at the very top of this stack. So in this figure you can see the protocols listed for each of the 4 layers. So HTTP, FTP are application layer protocols, TCP and UDP are transport layer protocols, Internet Protocol version 4 and 6 are the internet layer protocols, and then we have the media access control protocol for the link layer. So the link layer is used to move packets between 2 different hosts on the same link or the same network. It adds a header to the packet to prepare it for transmission, then actually transmit this frame over a physical medium. So the TCP/IP model includes specifications of translating the network addressing methods used in the Internet Protocol to the link layer addresses, which are known as the media access control addresses. This layer also deals with issues like error detection, frame synchronization, and flow control. The layer above the data link layer is known as the internet layer. So this layer has the responsibility of sending packets across potentially multiple networks. So internetworking requires sending data from the source network to the destination network. So this process is known as routing. Therefore, the Internet Protocol performs two basic functions: host addressing and identification. This is accomplished through the use of the IP addressing system. The second function is the packet routing. So this is the basic task of sending packets of data from the source to the destination by forwarding them to the next network router, which is closer to the final destination. So the internet uses the Internet Protocol addresses or the IP addresses to identify destinations on the internet. So every device connected to the internet, as you can see from this figure, has an IP address, which is a numeric code that is meant to uniquely identify the device. So the Internet Protocol has two versions, IPv4 and IPv6. So the IPv4 addresses are the IP addresses from the original TCP/IP protocol. In IPv4, four numbers are used, which are implemented as four 8-bit integers. So that's a total of 32 bits. Therefore, the number of IP addresses that can be encoded are 2 raised to the power 32, which is equal to 4.2 billion addresses. Now, because the internet is constantly expanding and might cross this 4.2 billion address limit when more than that number of devices are connected to the internet. Therefore, a new version of the IP protocol was created, which is known as the IPv6. This version uses 8 16-bit integers, so that's a total of 128 bits. So the total number of addresses now are 2 raised to the power 128, which is over a billion times the number of IPv4 addresses. So these 16-bit integers are normally written in hexadecimal due to their longer length. The layer above the internet layer is known as the transport layer. The goal of this layer is to make sure that the packets arrive in order and without any error. So for this purpose, the packets use the TCP protocol or the transmission control protocol. So first, the messages are divided into packets, and each packet is assigned a sequence number so that it can be reassembled in the correct order at the destination. Secondly, each packet is acknowledged back to the sender so that in the event of a lost packet, the transmitter will realize that a packet has been lost because no acknowledge was received for that packet. So as you can see in this figure, the acknowledgement for the second packet is not received in time. That packet is then retransmitted, and although it is not received in the correct order, it is reordered at the destination through the use of sequence numbers. The last layer or the top layer in the stack is the application layer. So protocols at this layer implement process-to-process communication. So the web developers only deal with protocols in this layer. So for example, HTTP or the Hypertext Transfer Protocol, which is used for web communication, the SSH protocol, which is the Secure Shell Protocol that allows remote command line connections to servers. Then the FTP protocol or the File Transfer Protocol, which is used for transferring files between computers. The POP, IMAP, or SMTP protocols, which are email-related protocols for transferring and storing emails. And finally, the DNS, or the Domain Name System Protocol, which is used for resolving domain names to IP addresses. So let's now look at the client-server model of communication. So the web is also referred to as the client-server model of communications. So we have the servers, which are computers that are always active, and they listen to queries from the clients who make requests for resources. So the servers act as the central hub of the model, and they host web applications, they store user and program data, and they perform security authorization tasks. The clients, on the other hand, are the computers that make requests to the servers and they get back responses. So these responses consist of the data that they requested. So the client machines are desktops, laptops, smartphones, and tablets. So example of client requests are the requests for web pages through a web browser, or a game that communicates with a game server using HTTP. Therefore, we have a request-response loop in this communication model where the client makes requests and the server responds to these requests. This is different from the peer-to-peer model of communication where a computer agent acts as both a client and a server. So it can both send and receive information. So this figure shows the peer-to-peer model of communication. You can see that all computers are functionally identical and are able to both upload and download information. Let's now look at the domain name system, or DNS. As we discussed a while ago, IP addresses are used to uniquely identify hosts on the internet. Therefore, every website has a unique IP address. However, imagine how unpleasant the internet would be if you had to remember IP addresses instead of the website's domain name. So rather than typing google.com, let's say you had to type 173.194.33.32 in the URL address bar. So when ARPANET was created, the number of internet hosts was small, so a list of a few hundred domain names and their IP addresses could be downloaded as needed from the Stanford Research Institute as a hosts file. So those key value pairs of domain names and IP addresses allowed people to use the domain name rather than the IP addresses. But as the number of computers on the internet grew, this hosts file had to be replaced with a better and more scalable and distributed system. So this system is called the domain name system. And it is used to resolve the domain names to their IP addresses. So when you type a URL inside the browser, your browser requests the domain name server for the corresponding IP address for this domain name. The server replies with the IP address, and the browser then sends an HTTP request to the web server at this IP address and gets back the requested page. So DNS is one of the core systems that make an easy-to-use internet possible. Since the entire request-response cycle can take less than a second, it is easy to forget that DNS requests are happening in all your web and email communication. A domain name can be broken down into several parts, known as levels. They represent a hierarchy with the rightmost parts being closest to the root at the top of the internet naming hierarchy. All domain names have at least a top-level domain name and a second-level domain name. So most websites also maintain a third-level www subdomain and perhaps others. So in a domain like funwebdev.com, the .com is the top-level domain and funwebdev is called the second-level domain. So normally it is the second-level domains that one registers. The owner of a second-level domain can elect to have subdomains if they so choose, in which case those subdomains are prepended to the base hostname. So for example, we can create projects.webdevfun.com as a domain name where projects is the subdomain. So again, the rightmost portion of the domain name, just to the right of the rightmost period, is called the top-level domain. For the top level of a domain, we are limited to two broad categories. The first one is the generic top-level domain, where we have unrestricted top-level domains, for example, .com, .net, .org, and .info. And we have the sponsored top-level domains, which are .gov, .mil, .edu. And the other category is known as the country code top-level domain. These include .us, .ca, .uk, etc. And these are under the control of the countries which they represent. So how are domain names assigned? They are assigned by special organizations or companies which are called the domain name registrars, which manage the registration of domain names. These domain name registrars are given permissions to do so by the appropriate generic top-level domain registry and or a country code top-level domain registry. So this figure illustrates the process involved in registering a domain name. So first you decide on a top-level and second-level domain name. So for example, funwebdev.com. So now you will contact a domain registrar who will check the availability of this domain name by asking the registry for the top-level domain you requested. So if this domain is available, you will complete the registration procedures and the payment. Also, in order for this domain name to be resolved to its IP address in future, the corresponding information for this domain name is sent to the top-level domain name server. So as I just mentioned, when you type the domain name of a website into the browser's URL address bar, eventually your browser needs to know the IP address of the website in order to request any resources from it. So the DNS provides a mechanism for software to discover this numeric IP address. This process is referred to as address resolution. So how does it work? This figure illustrates the domain name address resolution process. So this resolution process starts at the user's computer. So let's say the domain www.funwebdev.com is requested, perhaps by clicking a link or typing in a URL. So the browser will begin by seeing if it already has the IP address for this domain name in its cache. So if it does, it can jump to step number 13 in this figure to request the page from the web server at this IP address. If the browser does not know the IP address for the requested website, it will delegate the task to the DNS resolver, which is a software agent that is part of the operating system in your computer. So the DNS resolver also keeps a cache of the frequently requested domains. So if the requested domain is inside the cache, then the process jumps to step number 12 in the figure and returns the IP address of the website. Otherwise, it must ask for outside help, which in this case is a nearby DNS server or a special server that processes DNS requests. This might be a computer at your internet service provider or at your university or corporate IT department. The address of this local DNS server is usually stored in the network settings of your computer's operating system. So this server keeps a more substantial cache of domain name IP address pairs. If the requested domain is in its cache, then the process jumps to step number 11 to return the IP address of the website. So if the local DNS server does not have the IP address for the domain inside its cache, then it sends out the request to the root name server, which returns the IP address of the name server for the top level domain, or .com in this case. So now the primary DNS server will request the .com name server to return the IP address of the DNS server for funwebdev.com. The primary DNS server will then request the IP address of funwebdev.com from the DNS server. So this DNS server returns the IP address of the web server for funwebdev.com, which is step number 10 in the figure. So now let's take a look at uniform resource locators. So a uniform resource locator, or a URL, is a naming mechanism for the web to allow the clients to request resources from the server. So here is an example of a URL. So it has several components. So the first part is the application protocol that is used to connect to the server. So in this case, it is HTTP, or the Hypertext Transfer Protocol. It can also be FTP, which is the File Transfer Protocol. So the second part is the domain name that identifies the server from which we are requesting the resources. So this part is case insensitive. As we just discussed, this domain name is the one that is resolved into an IP address. So you can also use IP address here instead, but that is usually not the case. Then we have three optional components: the path, the query string, and the fragment. The path is the path to the resource on the web server. The query string is used for passing information such as user input from the client to the server. So in URLs, they are encoded as key-value pairs delimited by the ampersand symbols and preceded by the question mark symbol. Sometimes fragments are used in the URL as a way of requesting a portion of the web page. So browsers will see the fragment in the URL, seek out the fragment tag anchor in the HTML, and scroll the website down to it. Let's look at the Hypertext Transfer Protocol. The Hypertext Transfer Protocol, or HTTP, is an application layer protocol that is an essential part of the web. The HTTP protocol establishes a TCP connection on port 80. The server waits for the request and then responds with a response code, headers, and an optional message that can include files. The experience of seeing a single web page is facilitated by the client's browser, which requests the initial HTML page, then parses the return HTML to find all the resources referenced from it, like images, style sheets, and scripts. Only when all the files have been retrieved is the page fully loaded to the user. This figure shows the HTTP request and response. There are headers included in the HTTP request sent by the client and in the response received from the server. These headers encode the parameters for the HTTP transaction to define what kind of response the server will send. So in the request headers, the first one is the host header, which allows multiple websites to be hosted off the same IP address. Since requests for different domains can arrive at the same IP address, the host header tells the server which domain at this IP address the client is interested in. Then there is a user agent string, which tells us what kind of operating system and browser the client is running. The next is the accept header, which tells the server what kind of media types the client can receive in the response. The server must adhere to these constraints and not transmit data types that are not acceptable to the client. Then we have the accept encoding header, which specifies what types of modifications can be done to the data before transmission. This is where a browser can specify that it can unzip or deflate files compressed with certain algorithms. Similarly, there is the accept language header. Then we have the connection header, which specifies whether the server should keep the connection open or close it after the response. Although the server can abide by the request, a response connection header can terminate a session, even if the client requested it to stay open. Then we have the cache control header, which allows the client to control caching mechanisms. This header can specify, for example, to download only the data if it is nearer than a certain age, and never re-download if it's cached, or always re-download. So proper use of this header can greatly reduce bandwidth. Similarly, in the response header, we have a server header that tells the client about the server. It can include the type of operating system the server is running, as well as the web server software that it is using. Then we have headers about the content. The content length header specifies how large the response body will be. The requesting browser can then allocate an appropriate amount of memory to receive the data. To accompany the request header accept, the response header content type tells the browser what type of data is attached in the body of the message. The content encoding header is used by the server to specify to the client how the content was encoded so that it can be decompressed if needed. While we as web users might be tempted to think of an entire page being returned in a single HTTP response, this is not what actually happens. In reality, the experience of seeing a single web page is facilitated by the client's browser, which requests the initial HTML page, then parses the return HTML to find all the resources referenced from within it, like images, style sheets, and scripts. Only when all the files have been retrieved is the page fully loaded to the user. You can see this whole process using the developer tools provided by modern browsers such as Chrome. So if you right click on the page and click inspect and then choose network and then try to visit a web page, you will see all the resources being returned by the server, and you'll also see additional information about each of these resources. The HTTP protocol defines several different types of requests, each with a different intent and characteristics. The most common requests are the GET requests and the POST requests. In the GET request, one is asking for a resource located at a specified URL to be retrieved. When you click on a link, type in a URL in the browser, or click on a bookmark, you are usually making a GET request. The POST request method is normally used to transmit data to the server using an HTML form. So the first image in this figure is showing a form, and so the HTTP request method is POST, while the second image in this figure is showing a hyperlink. So when you click on the hyperlink, you are actually making an HTTP GET request. Finally, let's look at web servers. So a web server is a computer that responds to or serves HTTP requests. So every web server requires an application stack in order to run a website. So this stack comprises of four things: operating system, a web server software, a database, and a scripting language. So the two most common web stacks are the LAMP software stack and the Visa software stack. The LAMP software stack refers to combination of the Linux operating system, the Apache web server, the MySQL database, and the PHP scripting language in order to process dynamic requests. The next one is the Visa software stack. This is the other option used by corporations, and it stands for the Windows operating system, the IIS web server, the SQL Server database, and the ASP.NET server-side development technology. So let's recap. In this lecture, we first started off with a brief history of the internet and the web. Then we looked at the internet protocols. So we looked at 4 layers and the protocols on each layer. Then we looked briefly at what a client-server model is and how it is crucial to the functioning of the web. Then we looked at domain name system, which is used for resolving a domain name to the IP address. Then we looked at the uniform resource locators. We looked at the HTTP protocol, the hypertext transfer protocol, which is an application layer protocol used in web communications. And finally, we briefly looked at the web servers.